In 2022, a team of researchers at the University of Geneva asked an AI system to help them identify molecules that could be used as chemical weapons. They weren't trying to build anything. They were running an experiment to see if publicly available AI drug discovery tools could be repurposed for harm. In 6 hours, the AI generated 40,000 candidate compounds. Several were more toxic than any known chemical weapons agent. They published the paper as a warning. Almost nobody read it. You are probably using AI tools today, maybe for work, maybe for writing, maybe just to answer questions. The same underlying architecture that helps you draft an email is, in a different configuration, helping researchers around the world model protein structures, predict viral behavior, and synthesize novel biological compounds at a speed that no human team could match. That capability has saved lives. It accelerated COVID vaccine development by years. It is identifying cancer drug candidates that would have taken decades to find manually. It is also, right now, accessible to people who do not have good intentions. For most of human history, creating a dangerous pathogen required a nation-state, a military bioweapons program, specialized containment facilities, trained virologists with decades of experience. The barrier to entry was enormous, intentionally so. In 2024, the Johns Hopkins Center for Health Security published an assessment concluding that AI-assisted biological design has reduced the technical expertise required to engineer a dangerous pathogen to the level achievable by a graduate student with access to commercial DNA synthesis services and an off-the-shelf AI model. A graduate student. The barrier didn't fall slowly, it collapsed. The FBI's Weapons of Mass Destruction Directorate issued an internal advisory in 2023, noting that the convergence of large language models, protein folding AI, and accessible gene synthesis represents a biosecurity threat without historical precedent. Not a future concern, a present one. This isn't science fiction. The tools exist. The knowledge is increasingly accessible. And unlike a nuclear weapon, a biological agent doesn't require rare materials, massive infrastructure, or a detectable supply chain. It requires biology. And biology is everywhere. If this is your first time on the Doomsday Archive, subscribe now. We cover the threats science confirms are real. This one keeps biosecurity experts awake at night in a way that almost nothing else does. And in Part 2, we're going to explain exactly how an AI-designed pathogen would be built, not to instruct, to make you understand why the people responsible for preventing this are genuinely frightened.
So how does it actually work? Understanding the mechanism isn't dangerous, it's necessary, because the people making policy decisions about this threat are, in many cases, still thinking about bioweapons as a Cold War problem, something that requires state resources, something that happens in a facility with a fence around it. That world is gone. Modern AI systems trained on biological databases, and there are dozens of them, openly published, used daily by legitimate researchers, can perform a task called inverse protein design. You give the system a desired outcome, a specific receptor it should bind to, a specific immune response it should evade, a specific transmission characteristic it should optimize for. The AI works backward from the outcome to the sequence. It doesn't need to understand what it's doing. It doesn't need a hypothesis. It runs optimization across billions of possible configurations and returns candidates ranked by probability of achieving the target. In 2023, a research team at MIT demonstrated that a publicly available protein design AI could generate novel pathogen surface proteins that existing antibody libraries, the foundation of most vaccine development, had never encountered. Proteins that human immune systems would have no prior recognition of. No recognition means no innate response. No innate response means the body doesn't begin fighting until the pathogen has already established itself. Think about what that means for you specifically. Every vaccine you have ever received works by showing your immune system a version of a threat so it recognizes the real one. Flu vaccine, COVID vaccine, childhood immunizations, all of them depend on the principle that the pathogen looks like something the immune system has been trained to see. An AI-optimized pathogen can be designed to look like nothing your immune system has ever seen, not because it evolved that way over millions of years, because an algorithm spent 48 hours optimizing exactly for that property. And here's what they're not telling you in the mainstream AI safety conversation. The biosecurity and AI safety communities are largely separate. They attend different conferences. They publish in different journals. The people building the guardrails for large language models are mostly not the people who understand gain-of-function research. And the people who understand gain-of-function research mostly don't have input into AI development pipelines. The gap between those two communities is where the risk lives. DNA synthesis, the physical process of printing a biological sequence, is a commercial service. You submit a sequence online, a company prints it and mails it to you. There are screening protocols. They are incomplete. A 2023 audit by the Nuclear Threat Initiative found that fewer than half of commercial DNA synthesis providers had adequate screening for dangerous sequences. Fewer than half. In Part 3, we place you inside a pandemic caused by something that was designed, not discovered. And the difference between those two words is the difference between every pandemic response tool humanity has ever built and nothing.
It begins in 3 cities simultaneously. That detail is important. Natural pandemics don't begin in 3 cities simultaneously. They begin in one place, spread along travel corridors, and give epidemiologists a trail to follow. Patient 0, index case, geographic origin point. A deliberately released AI-optimized pathogen doesn't have to follow that pattern. You are a 41-year-old teacher in Chicago. It is a Thursday in October. You have a headache. You assume it's the dry autumn air. You take ibuprofen and go to school. You teach 112 students that week. The pathogen you are carrying was optimized for a 12 to 16-day incubation period, long enough that you infect your contacts well before you show any symptoms. Long enough that contact tracing, the backbone of every pandemic response protocol, becomes mathematically impossible before public health authorities even know there is an outbreak. COVID-19 had a 5 to 6 day average incubation. Epidemiologists called that challenging to contain. 12 to 16 days with high pre-symptomatic transmission is not challenging. It is uncontainable by current methods. By the time the first hospitalization cluster triggers a CDC alert, day 18, the pathogen is in 43 states. The genome sequence comes back from the NIH reference lab on day 21. It matches nothing in the database, not a variant, not a known family, something new. The standard vaccine development pipeline, even accelerated by mRNA technology, requires 3 to 6 months from sequence identification to first doses. During COVID, that timeline was considered a miracle of modern science. 3 to 6 months of uncontrolled spread for a pathogen optimized to evade existing immunity. Now you're not the teacher anymore. You're a parent in Atlanta. Your daughter is 7. Her school closed 4 days ago. Your hospital system sent an alert this morning saying non-emergency services are suspended. Your employer sent a work-from-home notice, but your job is in a warehouse. You have 11 days of food in your house. You have a 7-year-old asking why she can't see her friends. You have a phone full of news that is contradicting itself every 4 hours. And somewhere in a government laboratory, scientists are looking at a genome sequence that shouldn't exist, trying to figure out whether what they're seeing was designed, and if so, by whom, and if so, where. Those questions take months to answer. The virus doesn't wait for the answers. In Part 4, we talk about what the global response infrastructure actually looks like, what was built after COVID, what was funded, and one specific preparedness gap that the WHO identified in 2024 as the single highest risk failure point for an engineered pandemic scenario. It involves the first 72 hours, and right now, no country on Earth has closed it. So what has been built since COVID? More than before, not enough for this. The international health regulations, updated after COVID, require WHO member states to report unusual disease clusters within 24 hours of detection. In practice, the average reporting delay in the 2022-2024 period for novel pathogen events was 11 days. 11 days under the updated rules with the lessons of COVID supposedly learned. 11 days is most of the pre-symptomatic transmission window of the scenario we just described. The United States' BARDA, the Biomedical Advanced Research and Development Authority, has invested significantly in platform vaccine technologies since COVID. The mRNA infrastructure is real. The capacity exists to move faster than ever before. But BARDA's acceleration models assume a known pathogen family, a sequence that gives researchers a starting point. An engineered pathogen optimized to resemble nothing in the database gives them a blank page. In 2024, the WHO's Scientific Advisory Group for the Origins of Novel Pathogens published an assessment identifying engineered pandemic agents as a Tier 1 biosecurity threat, the highest classification. The report specifically noted that existing global surveillance infrastructure was designed for naturally occurring pathogens and has structural blind spots for deliberate release scenarios. Structural blind spots in the WHO's own language. Here's what they're not telling you. The countries with the most advanced AI capabilities, the ones whose research institutions are producing the tools that make this scenario possible, are also the countries with the weakest international biosecurity cooperation agreements. The geopolitical fractures of the last decade have directly degraded the information sharing frameworks that early detection depends on. When the next novel pathogen appears, the first question will be, is this natural? The answer to that question determines everything about the response. And right now, the forensic tools to answer it within the critical 72-hour window do not exist. You are a nurse in a Houston emergency department. It is day 17 of the outbreak we described. Your hospital is at 140% capacity. You have been on shift for 14 hours. You have not been told whether what you are treating is natural or engineered because nobody has confirmed it yet. You are wearing the same PPE you wore for COVID. You don't know if it's adequate. Neither does your hospital's infectious disease team, because adequacy depends on transmission characteristics that are still being modeled. You go back to the next patient. If this video is making you think about what preparedness actually means at a personal and community level, hit the like button, share it. The conversation about AI biosecurity is happening almost entirely behind closed doors. It belongs in the open. In Part 5, we talk about probability, about the specific actors the intelligence community is watching, and about a 2024 regulatory development that may be the most important thing that happened in biosecurity this decade, and that almost no one covered.
So, what are the actual odds? In 2023, a survey of biosecurity experts conducted by the Johns Hopkins Center for Health Security asked respondents to estimate the probability of a large-scale biological event caused by an engineered pathogen within the next 25 years. The median response, over 50%. Not a fringe estimate, the median among the people whose profession is understanding this threat. 1 in 2 before 2050. The intelligence community's assessment is classified, but what has leaked into public testimony and declassified threat assessments is consistent with that number. The 2024 Annual Threat Assessment of the U.S. intelligence community listed biological threats, specifically including AI-enabled pathogen development, as a top-tier national security concern for the third consecutive year. Now, make it personal one final time. You are 63 years old. You survived COVID with complications that left you with reduced lung capacity. You live alone. Your adult children are in different states. You have a primary care physician you see twice a year. In the scenario we've described, the medical system that you depend on, that you have paid into your entire working life, is the first system to fail. Not because doctors stop caring, because a hospital operating at 140% capacity with an unknown pathogen and inadequate PPE guidance is a place that cannot safely treat you for anything. Not the pathogen, not your heart condition, not the broken arm from the fall you had last year that never quite healed right. The compounding effect of a novel engineered pandemic isn't just the pathogen, it's the collapse of routine medical care for everyone else simultaneously. That 63-year-old is someone's parent, someone's neighbor, someone reading this right now. Here is what separates this threat from almost every other scenario on this channel. Cascadia will happen in one region. La Palma will affect one coastline. Kessler debris will affect infrastructure globally, but leave people physically intact. An engineered pandemic has no geographic boundary, no infrastructure that can be hardened against it, and no warning system that currently functions within the critical early window. What exists is research and regulation, and the slowly building international consensus that the convergence of AI and biology is the defining biosecurity challenge of this decade. The 2024 International Biosecurity and Biosafety Initiative, signed by 31 nations, established the first binding framework for AI screening requirements in biological research. 31 nations out of 194. The window to build the infrastructure that closes this gap is the same window that exists to prevent the scenario we've described tonight. It is open, it is not wide, and it is not staying open by itself. Subscribe to the Doomsday Archive so you're here for what comes next. Because next week, we're covering a threat that requires no technology, no AI, and no laboratory. It has been building for decades inside the soil beneath the cities where you live. It has already begun, and the infrastructure it is destroying carries the drinking water of 200 million people. Governments know the repair bill is why they've stayed quiet. This is the Doomsday Archive. Tomorrow is coming. Will you be ready?